So we will today discuss about something related to JEE Advanced Mathematics. Okay. So let us start our discussion with any topic relevant to us. Today we'll be discussing about again set theory and real number system. So we'll just see and focus ahead. What is universal set? Okay. That we'll try to understand. What is universal set? Universal set. So we can say that any set which is superset of all sets under consideration. Any set which is superset of all sets consideration under consideration is called the universal set, and it is denoted by by S or U. Okay. A universal set can be chosen arbitrarily for any discussion of given sets, but once chosen, it is fixed for that discussion of the sets. Let us say we have, for example, let us say we have a set A having elements that is 1, 2, 3, B having elements 3, 4, 6, 7, 8 and 9, and we have one more that is C 0, 1. We can consider U. So in this case U 0, 1, 2, 3, 4, 6, 7, 8 and 9 will be there as a universal set, as universal set. Okay, so this is the smallest universal set in this discussion. Right now in this discussion I can say that A is a set of 3 elements, B is a set of, you can say, 6 elements, and C is a set of 2 elements. So universal set here consists of 10 elements, which contains all the elements, or you can say it is a superset containing all of the three subsets, that is A, B and C. So let us now discuss about what is Venn diagram. This was a discussion related to universal set. What is Venn diagram? Let us try to understand. What is Venn diagram? So whenever we are using relationships between sets, and it can be represented by the means of diagrams. So we can just make a definition here: relationship relationships between sets represented by means of diagram are known as Venn diagram. Are known as Venn diagram. Okay. So Venn diagrams are named after the English logician John Venn. These diagrams consist of rectangular and closed curves using usually circles. The universal set is represented usually by a rectangle and its subsets by circles. In Venn diagram, the elements of the sets are written in their respective circles. Now let us take an example to understand this. So here the basic features, let us first try and understand. Here, named after English logician John Venn. These diagrams consist of rectangles and closed curves. So these diagrams consist of rectangles. These diagrams consist of rectangles, usually these diagrams consist of rectangles and closed curves curves. Circles, basically circles are there. Okay, now let us go further. The universal set is represented usually by a rectangle. universal set here. Universal set is represented by a rectangle. Okay, and its subset by circles. And here a few other features are, you can say elements of the sets are written in their respective circles. Elements of the sets are written in their respective circles. Okay. So let us take an example, a very very small example where we have U having elements as 1, 2, 3, 4, 5, 6, 7, and 8, and one subset and one subset E is 2, 3, 5, 7. So Venn diagram can be Venn diagram Venn diagram for the sets, for these sets is, so for this firstly I need to draw I need to have a, let's say, circle. Okay, circle, I'll take this circle I've taken. Okay, now I'll just try to uh, take a big rectangle consisting of sides. So we have here U and E. 2 is there, 5 is there, 3, 7, 1. So 2, 3, 5, 7, 2, 3, 5, 7, 1, 4, 6, and 8 we are keeping here. So this is the representation uh, here. So we have U here, that is 1, 2, 3, 4, 5, 6, 7, 8, and A is having 4 elements. So 4 elements we have shown inside the circle representing the element belonging to A, and now U should have everything. That's why already 4 will not count it again. It is already there in the U, also in A, and then the remaining 4 we will maintain here outside A, because this 4, that is 1, 4, 6, 8 doesn't belong to A, but they are in the universal set. Okay, so this is the concept. behind this particular part. Okay, so less more we can say slightly more discussion is required here, I will say. We can keep something more with us. Okay, in this same diagram, if I'm going to construct something else, let me just try to construct something else also. Let us say this is 5. If I just construct one more circle there inside, okay, so I'll just take out 7 somewhere. So here I have drawn one more circle now consisting of certain elements. Let us mark it as B, and we can say that in B we have 2, 5 and 7, but we don't have in B in B we don't have 7 there, right? So we are just extending the example, like let B subset B is equal to 2, 3 and 5, and B is a proper subset of A. We can say that B is a proper subset of A because elements are not equal and it is lesser. It will call as a proper subset of A. So this is the representation, and circle for B is contained in the circle for A. Then above is the representation. Above is the representation. Is the representation. And above is the representation of. Okay. Okay. So we will be pausing here, and we'll discuss operation of on sets in the future discussion. Wait. So this is paused here. Okay.